I'm actually going to play it like I would if I was taking the test. So in behavior, so let me write this problem down because I'm going to write the chart again for y'all to use on this. So that's what, negative pi x to the 6th plus x to the 5th minus x to the 4th minus x plus 1. So let me bring my other screen up. So when they tell you to use the in behavior to determine what the picture will look like, we had a chart I gave y'all, and on the top it said degree, and then on the side it said lead coefficient. So there's going to be 4 cases on these. So you can have an even degree or an odd degree. So at the degree we look at if it's even or odd. And then the lead coefficient can be positive or it can be negative. So what happens on these, if you got an even degree and a positive lead coefficient, both sides of the graph are going to go uphill like a parabola. If it's an even degree and the lead coefficient is negative, then both sides are going to go downhill. Then you got to look at the odd degrees. If it's an odd degree and a positive lead coefficient, it went uphill left to right. And then the last choice was if it was an odd degree and a negative lead coefficient, it went downhill left to right. So these are your 4 cases. So what you do, you got to look at your degree first. So the degree is the largest exponent. So this one has a degree of 6. So it's an even degree. Then you look at the lead coefficient, which is the number in the front. Is the number positive or negative? Well, mine is negative. So I got an even degree, negative lead coefficient, which means this picture should go downhill on both sides. So when we pull that up to look at their answers, the one that goes downhill on both sides would be our choice C on this one. So keep that picture of that chart because you'll use that on problem 1, and I believe problem 2 you can use it on. So the same thing, choose the in behavior. So now the highest degree on this one would be a 7. So you got an odd degree. The number in front of it is a 0.4, which is positive. So if you look at your chart, we had a negative degree and a positive lead coefficient. So when your degree is odd, and then I said what, a positive lead coefficient, so my graph should go uphill left to right. So that's all I'm looking at on this is biggest exponent, even or odd, number in front, positive or negative. Now we'll say if in doubt, graph that, and it'll give you one of them 4 pictures, okay? So I said mine was odd. Now this one's out of order is what they did to you on it. So that 7 is the degree, it's odd, 0.4 is positive, so we shed that and should go uphill, left to right. All right, so this one I will work out. That's what a f of x equals x squared minus 9 squared. So it wants me to find the zeros and then state the multiplicity. So on this problem, to find the zeros and the multiplicity, we got to set what's inside the parentheses equal to 0. So x squared minus 9, we're going to set equal to 0. Then you're going to solve that. So 3 ways to solve that. You can factor it, you can use the quadratic formula, or you can solve it by square roots. I'm just going to factor that real quick because it will factor. So I got an x squared, that'll give me an x and an x. Last number's negative, so that's going to be 1 positive and 1 negative. And then that's perfect squares. So perfect squares, all you got to do is take the square root, which is 3 of that 9, and put a 3 and a 3. Factors of 9 that subtract and give me 0. Since there's not a number in the middle, it is a 0. All right, y'all then set both of these equal to 0 to finish solving them. Because remember, zeros means answers. So the first 0, when I subtract 3, I get a negative 3. The second one, I'll add 3 to solve it. And I get x is a positive 3. So my zeros are negative 3 and 3. The multiplicity is equal to the exponents that follow those parentheses. So let's look at how they're putting these answers in. So I got negative 3 and 3, and they have a multiplicity of 2. All right, so let's see. They got plus or minus 9. That's wrong. So we know those A's and C's are both wrong. All right, here we go. We got plus or minus 3, plus or minus 3. So they're using shorthand to get my 2 answers. And then we said these had a multiplicity of 2 because that was the exponent sitting outside those parentheses, okay? And then remember, if there's not an exponent down here, you got to treat it like a 1 on those problems. All right, so plus or minus 3, multiplicity 2, then we move on. All right, so I need to write this one down. That's a bigger one, right? So I got f of x is going to equal negative 5, x minus 3 squared, x plus 4 to the 4th, and then x to the 3rd. So same thing, we're going to find the zeros and state the multiplicity of each. All right, so we take all the factors and set them equal to 0 and solve them. But remember, the factors got to have a variable. So since this negative 5 is sitting here and it does not have a variable, cross it out. We don't need it. We can only set the variables equal to 0. So then take each of these factors, x minus 3, set it to 0, x plus 4 equal to 0, and then x equal to 0. Once we solve these, the multiplicities will be the 2, the 4, and the 3. So those are all the outside exponents that become the multiplicities. So we'll solve this one by adding 3. So I get the first 0 was x equals 3. Second one, we'll subtract 4. Get x is a negative 4. And then the last one, x equals 0, is already solved. So we're done. So I got a 0 of 3 with a multiplicity of 2. A 0 of negative 4 with a multiplicity of 4. And then a 0 of 0 with a multiplicity 3. So let's see how they want these answers in. So here you go, the 0, 3 had a multiplicity. So we got that from the first one, and we said that had a multiplicity of 2. And then this says blank is a 0 of multiplicity 4. Well, remember, we solved this one and got a negative 4. And then, y'all, the last one, the remaining 0 is 0, and it had a multiplicity of, we said, 3. So get your zeros and then sort of see over here how they're wanting them to be put in, okay? All right, so we would do that and then move on. All right, so let me write this one. This is probably the trickiest one. F of x equals x to the 3rd minus 8x squared minus a x plus 8. All right, so I'm going to find the zeros and their multiplicities. So let's go to the screen. Now, if y'all had foundations, y'all probably were good at this problem because y'all factored by grouping. And the way I'm going to solve this is factor by grouping. And you got to do that because you got 4 terms and you don't have any of them that are like terms. So the only way to factor this is by grouping. So by grouping, you're going to set this whole thing equal to 0. So grouping, you take the first 2 terms and group together, and then the last 2 terms and group together. And you find GCFs of each of those and you factor them out. So the first GCF and then the second GCF. So you got an x to the third and an 8x squared. The GCF between those 2 terms would be a x to the squared. That's the most that they have in common, okay? So you factor out that x to the squared. And in parentheses, you put what you get when you take x to the third minus 8x squared and divide both them by that x squared. So x to the third divided by x squared will leave me at x minus 8x squared divided by x squared. The x squareds would cancel and you're left with the 8. Now, second GCF always has the same sign as that third term. So since it's negative, the second GCF will be negative. And then once the x and an 8 got in common, y'all, the only thing they got in common would be a 1. So the second GCF will be a negative 1, and then I'll have my parentheses. So once again, to get the parentheses, I take both of these and divide by negative 1. So a negative x divided by negative 1 makes that a positive x. And then you got a positive 8 divided by negative 1. That's going to make that a negative 8. If you notice, my parentheses match up. So that's what I needed. So after that, you go right to your parentheses. And remember, all this is still technically set equal to 0. So at this point, what's in the parentheses will become one factor. What's outside the parentheses will become the second factor. So since the parentheses match, we factor out the x minus 8. If we factor out that x minus 8, all that's left is the x squared minus 1. All right, so it is now technically factored. So now we take both of our factors and set them equal to 0. So y'all, the first one's not bad. That's just the x. So all I got to do to that one is add 8. And I get my first 0 is 8. Second one, that is perfect squares. So I'm going to factor it real quick. That's an x squared, so that's going to be an x and an x. Last number is negative, so that's going to be 1 positive and 1 negative. And then factors of 1, that'll subtract and give me a 0 or 1 and 1. Only had one guess on that, and anytime you got a prime number, that's the only choice you got, okay? All right, so now finish this out by setting those equal to 0. Subtract 1, so you get x is a negative 1. And then on the last one, I'm going to add 1. And get, add 1 and get x equals 1. I was counting all my zeros and about to put a 3 there, y'all. So notice, if you got an exponent of 3, that's your largest exponent, you're going to get 3 zeros, okay? So I got an 8, a negative 1, and a 1. And up here where I had it factored, since I don't have parentheses outside these with exponents, it would be like they both had a 1 by them. So all my zeros got a multiplicity of 1. So let's go put that in. So you would come in here and the zeros were I got a 8, comma, 1, comma, -1. And then each zero had a multiplicity of 1. And y'all, then we move on to number 6. So true or false? They give me a polynomial, x minus 8 squared, x plus 4 to the 5th. Then it's telling me y equals p of x crosses the x-axis at 8, 0. What does think about this? They're playing with this factor since they're talking about the 8. And we know that when you're attacking the x's inside the parentheses, you actually do move opposite of what that sign is. So since they're subtracting 8, it's really going to move my graph to the right 8 units, which would indeed cross at 8, 0. So that's going to be true. And then also you got to remember on these, if they got even exponents, they're tangent to the x-axis. If they got odd exponents, they cross through it. So we know this went right to the 8, but did it cross through it or did it be tangent? So since this is an even exponent of a 2, it would be tangent to the x-axis instead of crossing the x-axis. So overall, it would be false. And let's see, so since the exponent 2 is even, the graph is tangent, so we would have to go with B. Now, C says it's false, which is true, but they're saying the exponent 2 is odd, and 2 is not odd, it is even. So these two where they got 2 being odd, you might as well throw them out and just figure out, is it going to be true or false? If nothing else, graph it and see what it does when it crosses over there at that 8, okay? But when you look at these, find which factor you're talking about. Since I had 8, 0, I knew I was talking about the factor with the -8. And then just look at that exponent, even, tangent, odd, crosses through. All right, so we're going to find the maximum zeros, the maximum x-intercepts, and the maximum number of turning points. So the degree of this polynomial is 3, right? So we know that the maximum number of real zeros is equal to the degree, which is 3. Well, zeros and x-intercepts are basically the same thing. So if you got a maximum of 3 real zeros, then you're going to have a maximum of 3 x-intercepts. And then the turning points is always the degree minus 1. So since your degree is 3, your maximum turning points would be 2. So real zeros equals the highest degree. X-intercepts equals the highest degree. Turning points equals the highest degree minus 1. All right, y'all, so then you would move to 8. So sketch the graph of the polynomial. So I'm going to show you a trick that I do on this one. So I got h of x equals x times x minus 2 times x plus 1 times x minus 7. So let me show you what I would do to that real quick. I sort of like to multiply all the x's together to see what kind of degree I would get. So this x times x is an x squared, times this x is an x to the third, times this x is an x to the fourth. So my x's multiply to give me an x to the fourth. And then I'm going to look at the lead coefficients, which is all the numbers in front of the x's. Remember, since there's not numbers there, we treat every x like it's got a 1 in front of it. So the lead coefficient is going to be 1 times 1, which is 1, times 1, which is 1, times 1, which is 1. So the lead coefficient is like a 1. So we got a 1x to the 4th. It's got an even degree, a positive lead coefficient. So in the big picture, it should go uphill both sides. So let's find which one is going to match that. So you see this first one sort of looks like it's going uphill left to right. The second one, both sides are going downhill. The third one, both sides are going uphill. And then the fourth one is going uphill left to right. I needed the one that went uphill on both sides, so I would pick C. And then y'all, I would move on. All right, what's this one say? Graph the polynomial. So I'm going to use that chart again. I got it because they're giving me all the pictures. So x to the third, 6x to the third is my leading term. So my degree is a 3, which is odd. My lead coefficient is a positive 6. So an odd degree, positive lead coefficient goes uphill left to right. So that's going uphill both sides. That's going downhill. Oh, look at this. That's going uphill left to right. That one's going uphill left to right. So what we got to do is zoom these in and find which one's crossing the y-axis at 16. So y'all, that's pretty close to a 16 it looks like. Let's zoom in D and see what it's doing. So remember, the y-intercept is the last number. So 16, that's pretty close to looking like a 16. This one looks like it's crossing the y-axis right at the 0. We needed to cross at the 16, so we got to pick C. So when you got two graphs close like that, look at that last number because that's going to be your y-intercept and see which one's crossing at 16. All right, so I need to write this one down. So they want me to use synthetic division to determine whether these two numbers are zeros. The two numbers are -2 and 1. My polynomial is h of x equals x to the 4th plus 2x to the 3rd plus 2x squared minus 8x plus 3. So to determine if them two numbers are zeros, I'm going to do synthetic division. If I get a 0, I put yes. Any other number, I'm going to put no. So let me run the -2 since it's first. I'll do -2. Remember, we got to write down all the numbers. So I got a 1 for the x4, a 2, a 2, a -8, and a 3. So let me draw my little box. So I'm looking for a 0 remainder in my last box, okay? So synthetic division, you bring the first number down every time. Anytime a number's down here, you multiply by the C to get the next number in the column. So 1 times -2 is -2. Then I add 2 and -2. I get a 0. Now I take the 0 times the -2, which is 0. I add the 2 and 0 and get a 2. Then I multiply 2 times -2 to get a -4. Add -8, -4 to get a -12. And then finally, -12 times -2 is 24. 3 plus 24 gives me 27. So -2 is not a 0. So then what I'll do, I'll run the 1, because that was the second number they gave me. All the coefficients will be the same. 1, 2, 2, -8, and 3. So once again, I'm looking for a remainder of 0. It'll be yes. Anything else will be a no. All right, so the first number we bring straight down. 1 times 1 is 1. 2 plus 1 is 3. Then we do it again. 3 times 1 is 3. 2 plus 3 is 5. Then we do it again. 5 times 1 is 5. Negative 8 plus 5 is negative 3. Then we do it again. Negative 3 times 1 is negative 3. Oh, and y'all look at that. 3 and negative 3 give me a remainder of 0. So for 1, it would be a yes. So we would go in and put no yes for that answer. So is negative 2 a 0? We said no. Is 1 a 0? We said yes. Okay, so just knock out synthetic division twice on that and be done. Oh, these are the ones y'all love, these. So let me write what I got. Polynomial degree 4, so I need a degree 4. So when you're done, the biggest exponent has to be a 4. So negative 2 is a 0, a multiplicity 3. And then 0 is a 0, a multiplicity 1. All right, so we know we're going to be doing some foiling on this, okay? Anytime they say find a polynomial, you know you're doing some foiling. So they told me negative 2 is a 0 with multiplicity 3. So that means x equals negative 2, x equals negative 2, x equals negative 2. Then they said 0 is a 0, a multiplicity 1. So that means x equals 0. All right, so remember, set all these equal to 0. That one's done. So the other 3, you would add 2 to both sides so that you would get x plus 2 equals 0. So I gave y'all one of these, I think, on my bonus to work, similar to this. So let me show you what I'm going to do. Since this is a single variable, I'm just going to bring the x and put it first, and then I'm going to put all these x plus 2s. And set all this equal to 0. So guess what? We're going to FOIL this. And y'all, I'll tell you a trick. If you wanted to, you could distribute right here. Knock out 2 stones with 1 pass. So since I'm doing 2 things, when I'm done, I'll have 2 sets of parentheses, okay? One for the first part I'm distributing, and then this one for my foiling. So to distribute, x times x is an x squared. X times 2 is a positive 2x. So that takes care of the first one. Now over here, I'm going to FOIL and put that answer here. X times x is x squared. X times 2 is 2x. 2 times x is another 2x. And then 2 times 2 is a 4. Now, if you wanted to, you could FOIL this stuff at this point, but I'm going to make mine a little bit smaller by adding like terms real quick. So let me bring down the first parenthesis, x squared plus 2x. And then let's add the like terms. So the x squared comes down. 2x's plus 2x's gives you 4x's. Bring down your plus 4, all equal to 0. Okay, so now I've got parentheses times parentheses, so I'm going to FOIL this again. But y'all, this is a 2 by 3 FOIL, not just a 2 by 2, okay? It's like a FOIL on steroids because you got 3 things over here. So everything over here multiplies by everything over here. So x times x squared is x to the 4. x squared times 4x is 4x to the third. X squared times 4 is a 4x squared. All right, now I do the 2x. 2x times x squared is a 2x to the third. So I'm just adding those exponents as I go. 2x times 4x is a 8x squared. And then 2x times 4 is a positive 8x. All equal to minus 0. So at this point, all you can do is add like terms. So the x4 comes down. Add your x to the thirds together. So you got 4 and 2, so you got 6x to the third. Add your x squareds together. 4x squared plus 8x squared gives you 12x squareds. And then at the end, it'll be what? A positive 8x, all equal to 0. What was the question, y'all? No question? All righty. Now, am I happy? Hey, they said I needed a degree 4. Oh, my bad. My highest exponent is a 4. So when you're done, your degree has to match what they said in that problem, okay? So x to the 4s plus 6x cubed plus 12x squared plus 8x. All right, so I might not write that big old answer in if they don't give me one to choose from. Now that's too much to do. So I'm going to move on to the next one. All right, so this one didn't really need no work. You just had to remember that imaginary zeros come in conjugate pairs and radical zeros come in conjugate pairs. So since they give me I is one of my zeros, my next one would be a negative I, comma. Now, 3 minus square root of 13 is like one number. So its conjugate would be 3 plus the square root of 13. The conjugate does not change the sign of the real number like the 3. It only changes the sign of the radical part, okay? That's why the quadratic formula had the plus or minus on the radicals, okay? So imaginary numbers like I always come in conjugates. Radical answers always come in conjugates. So y'all, that's all you had to do on that one, and then you move to 13. All right, so find the polynomial of lowest degree that has the given zeros. So I got a square root of 3 and a 3i. So we're going to have to work this one. All right, so here's the thing. If square root of 3 is a 0, then automatically a negative square root of 3 is going to be a 0, because we learned that. They always come in conjugates. And then also if 3i is a 0, that means negative 3i is also a 0. So this is like the problem I done a couple ago, except they're only giving you 2 of the zeros. You got to remember that these kind of zeros always come in conjugate pairs. So I got x equals square root of 3, x equals negative square root of 3, x equals 3i, x equals negative 3i. And then I need to get zeros over here, so add and subtract as you need. So I'm going to subtract square root of 3 from the first one. And you'll notice when you get done with these, all these parentheses will still be conjugates of each other. Right, that's x minus square root of 3. This one's x plus square root of 3. This one will be, what am I going to get? X minus 3i. And then this one will be x plus 3i. So if they're conjugate zeros, they're going to be conjugates when you write them out, okay? At this point, you put everything in parentheses. What's next? X minus 3i. and then x plus 3i. All this is technically equal to 0. Now, the reason I put them together because I'm going to FOIL these two together, and then I'm going to FOIL those two together. Remember, when you FOIL conjugate pairs of radicals, you get rid of the radicals. When you FOIL conjugate pairs of imaginary numbers, you get rid of the imaginary numbers. So since I'm doing two FOILs, both of these will end up in parentheses. So let's FOIL this one. X times x is x squared. X times square root of 3 is a positive square root of 3x. Negative square root of 3 times x is a negative square root of 3 times x. And then negative square root of 3 times a positive square root of 3 is a negative square root of 9. So since the 3's were both under the radicals, you multiply them together to get that 9. Now this side, I got an x times an x, which is an x squared. X times 3i is a 3ix. Negative 3i times x is a negative 3ix. And then negative 3i times positive 3i is a negative 9i squared. So here's what I'll take care of on this one. I see that those cancel because they're opposite in sign. I see these i's right here cancel because one's a positive 3, one's a negative 3. And then remember, I squared equals negative 1. So I'm going to make that I squared into a negative 1 and multiply that negative 1 times that negative 9 to make that a positive 9, okay? So watch this. Bring down the first parentheses and then your second parentheses. Bring down the x squared. Those canceled. So then it's going to be minus. Well, what's the square root of 9? Square root of 9 is 3. So check this out. When you multiply a radical times itself, the answer will be the number that was under that radical. All right, over here I brought my x squared. Those canceled in the middle. And then negative 9, we said multiplies by negative 1 to make it a positive 9. All right, so now that I got rid of all the radicals, I got rid of all the imaginaries, I'm going to FOIL this and get my last answer. So we was FOILing here, in here, and now we're going to FOIL here. So notice I got 4 zeros. When I'm done, my highest exponent will be x squared times x squared, which is a x to the 4. So 4 zeros, you better end up with a degree 4, okay? All right, x squared times 9 is a 9x squared. Negative 3 times x squared is a negative 3x squared. Negative 3 times 9 is negative 27. And y'all, this one did have one more step. Those are like terms. So I would bring down that x to the 4th. Let's see, we got 9x squareds minus 3x squareds. So that'll be, what, 6x squareds. Minus my 27 is all going to be equal to 0. So you're definitely getting your practice FOILing on this test, okay? But y'all, the main thing on this problem, when they say find the degree of polynomial of lowest degree, if they give you radical zeros and imaginary, you gotta put in those conjugates, okay? Ooh, okay, so that was the long stretch of this test, I guess. So let's go back. So we would put that in and move on. All right, so this is some synthetic division. They're giving me f of x equals x to the 3rd plus 3x squared minus 5x minus 15, and they're telling me they're giving me 1, 0, which is that negative 3. So let's go work this. So since this is an x3, we're going to pull out this 0, which is negative 3. Remember, whatever answer I get under my box, I can use the quad with to get the last two. So let's write our numbers down. We got a 1 for the x3, a 3 for the x squared, a negative 5 for the x, and then negative 15 for my number. Now, since they told me this negative 3 was one of my zeros, I just got to find the other two because remember, that's a degree 3. Altogether, it's going to have 3 zeros. They're giving me 1, so I'm going to find the last two. But since negative 3 is a 0, when you finish your synthetic division, that better be a 0 sitting there, okay? All right, so here we go. Bring down to 1. 1 times negative 3 is negative 3. 3 plus negative 3 is 0. 0 times negative 3 is 0. Negative 5 plus 0 is negative 5. Negative 5 times negative 3 is a positive 15. And y'all, negative 15 and 15 give me a 0. But we knew that. And we knew they gave me that first 0 of negative 3. So I'm going to use these three numbers right here to find the last two zeros. So remember, this is like an x squared plus a 0x minus 5, all equal to 0. So this is the answer, and it always starts out 1 degree less than your original polynomial. So since that was an x3, this had to start as the x squared, okay? So at this point, you really can't factor that because there's no factors of 5 that'll give you a 0. So you either got to use the quad or square root it. I'll use the quad formula. And hell, I'm going to do it by hand, but y'all got the calculator that can do this, right? So x equals negative b plus or minus square root b squared minus 4 times a times c. All of that's over 2 times a. So b was 0, so I put the two zeros in. A was a 1, and c was my negative 5. All right, so 0 times anything is 0. Under the radical, 0 squared is 0. Over here, you got a negative 4 times 1, which is negative 4. Negative 4 times negative 5 would be a positive 20 all over 2. So add the stuff under the radical. So you get 0 plus or minus square root of 20 over 2. So y'all, this is the point where you got to figure out how to simplify them radicals right there. You got a square root of 20. So you want to look at these perfect squares here. Two times 2, 3 times 3, 4 times 4, 5 times 5, and so on. Are any of these factors of 20? And yes, 4 is a factor of 20. So you got to break the 20 into a 4 and a 5. All right, so what's that going to do? That's going to give you 0 plus or minus. What's the square root of 4? The square root of 4 is 2. And then you got that square root of 5. All that's over 2. So now, since all three of these outside numbers will divide by 2, we got to divide them all by 2. So 0 divided by 2 is still going to be 0 plus or minus. 2 divided by 2 gives me 1 square root of 5. So my last two zeros are a plus or minus square root of 5. So y'all remember, y'all could have done that on this calculator. You would have hit program, go down to that quad program I sent you. So y'all might not have all those others, but just hit your quad. And then let's see, A we said was 1, B was 0, and C was -5. Now remember, the first time you hit enter, you get decimals. We don't want decimals, so hit enter one more time, and you get your plus square root of 5, negative square root of 5. All right, so let me go put that one in. So I tell you on that one, I would probably just use this little plus or minus button down here, and then that square root, and then put in my 5. Remember, I don't have to put the -3 because they gave me that one. They just want the under zeros. And it says type exact answers. That's why I could not use the decimals. It tells me to use radicals, okay? All right, y'all, so number 15 now. So list all possible rational zeros. So they're giving me f of x equals 14x to the 6th plus 11x to the 3rd minus 12x squared plus 10x plus 3. All right, so I'll work this one out for you. So to find all rational zeros, you got to take factors of the last number, which is 3. So that'll be like my P. And then my Q will be all the factors of the first number, which is 14. So remember, you take all factors of the last number, divide by all factors of the first number. So factors of 3 would be 1 and 3. Factors of 14 would be 1, 2, 7, and 14. Now remember, all the possible combinations can be positive or negative P over Q's, okay? So I'm going to write a plus or minus. The first P I'm going to use is 1. 1 divided by 1, which will be 1. Then you take 1 divided by 2. Can't do nothing to that. Then you take 1 divided by 7. Can't do nothing with that. Then you take plus or minus 1 divided by the 14. So my first, using the 1, I got a plus or minus 1, plus or minus 1/2, plus or minus 1/7, plus or minus 1/14. Then I got to take the 3 and do the same thing. 3 divided by 1, which is plus or minus 3. Then I take the 3 divided by 2. Can't do nothing with that. Then I take the 3 divided by 7. Can't do nothing with that. Then I take the 3 divided by 14. Cannot do nothing with that. So y'all be careful on these answers because some of them they don't put the plus or minuses on, and it can be plus or minus on those. So let me go over here, see what they're doing on these answers. So the first A does not have the 1 and 3, so I know it's wrong. The second one has 1, 2, 7, and 14. Well, I have nothing like that. The third one it doesn't have the 1 and the 3. But look at D. It's got a plus or minus 1 and 3, plus or minus 1/2, 1/7, 3/2, 3/7, 3/14, and then my 1/14. So all the answers I got were in D. Watch out, because looks like B, they took all the first numbers and divided by the last number, okay? But it's always factors of the last number divided by the factors of the first number, okay? So they trying to switch them up on you. All right, find the domain. So I got what? F of x, x3 minus x squared plus x plus 4. But remember, on the domain, I don't really care what's on the front, on the top. On the domain, I just care about what's on that bottom. All right, so let's go work this one real quick. So to find a domain, I take the bottom of this fraction, x squared plus 11x plus 28, and they cannot equal 0. I don't care about the top. It can be 0 all day long. The bottom cannot be 0, so that's why I'm only playing with the bottom. So that's the x squared, so I'm going to solve this by factoring. So x squared gives me an x and an x. the last number is positive. So anytime the last number is positive, both of these factors have the same sign as the middle number. So they're both going to be positive. All right, let's see. 1 times 28 is 28. 2 times 14 is 28. And 4 times 7 is 28. The one that adds to 11 is 4 and 7. All right, then you take both of them, set them equal to 0 to get your answers. Well, I mean not equal to 0, right? All right, so the first one I get, x cannot be a negative 4. The second one I would get, x cannot be a negative 7. So let me see how they wanted the answers in interval notation, or did they want them in set builder? So they're doing both. Okay. So I got 2 answers, so I need to use C because look, B only gives you 1 answer not to equal, but we got 2, and they want them in ascending order from small number to large number. So negative 7 is smaller than negative 4, so you got to put it first, and then put your negative 4. If y'all get them out of order, it'll mark it wrong, and you'll have to email me and tell me, hey, I had the right answer, but I put them in the wrong order so that I can give you credit. But remember, ascending order means the smallest number to the largest number, okay? Now, interval notation, I'm going to start with my parentheses. I start at negative infinity, so these will always start with negative infinity. So infinity's down here. And this one goes until you hit the first number, which is negative 7. Then arrow over, and then you union that one, next parentheses. You start at that negative 7, and you're going until you hit that negative 4. Then you arrow out of that, and you union that from that negative 4, and then over here to a positive infinity. So everybody better start with negative infinity and end with an infinity on that question. You're going to union around the 2 numbers that you found made it undefined. And I think the reason they wanted you to use ascending order here was when you use interval notation, remember you got to go left to right. So they're in the same order, negative 7 and negative 4 as they were up here. That's the only reason I can see them doing that to that answer for C, okay? All righty, so that one wanted them both, interval notation and set builder. And y'all, this is sort of the same, so let me write this. F of x equals negative 3 over x squared plus 3x minus 28. All right, so let me go back to my page. All right, so domain again, which means I take the bottom, and that bottom cannot equal 0. All right, so once again, I'm going to factor that because I got that x squared sitting there. X squared gives me an x and an x. This time, the last number is negative, which means you got 1 positive and 1 negative. All right, let me find my factors of 28 again. 2 and 14, and then what was the other one? 4 and 7. So since it's minus, I need the ones that subtract and get 7. Larger factor has the same sign as the middle, so 7 will be positive, 4 will be negative. Then set both of them equal to 0 and solve. Really, at this point, all you're doing is changing these signs, right? If the factor is positive, the answers are negative. If the factors are negative, the answers are positive. So we'll see if they want this one in interval or set builder notation. So let me go back. So I got what, a negative 7 and a 4. So they want interval notation. So once again, you would have the first parentheses. It's going to start at negative infinity. It goes until I hit my first answer, which was what, -7. Then arrow over in union from the -7 to the +4. Then you're going to arrow over in union. So if you got 2 zeros, you're going to have 2 unions. If you had 3 zeros, you would have 3 unions, okay? Right, then that goes from what, 4 until I hit positive infinity. So once again, our domain starts at negative infinity and it's got to end at positive infinity. You just got to figure out what numbers to kick out in the middle. All right, so horizontal asymptote, so that is f of x equals x squared minus 8 over 6x to the 4th plus 7. All right, so let me go back to the page. So horizontal asymptotes, you compare the degree. So the degree of the top is 2, the degree of the bottom is 4. So there's 3 cases on horizontal asymptotes. Top is greater than the bottom. Bottom is greater than the top, or the bottom equals the top. If the top's bigger than the bottom, then you have no horizontal asymptote. If the bottom is bigger than the top, then your asymptote will be y equals 0. If they're equal, your asymptote will be the ratio of A over B, where A and B are the lead coefficients. So notice what I got. My bottom degree 4 is bigger than my top degree 2, and anytime the bottom is bigger than the top, your asymptote is y equals 0. So let me go put that in. And y'all, it definitely, they got the y equals part already. So all we put in is the 0. So on every one of y'all, if that bottom is bigger than the top, you better be putting a 0 there. If they're equal, then you'll figure out A over B. And if the top was bigger, you would put there is no horizontal asymptote.
Can I answer the question? Sir?
Oh, did it not go to my screen?
No, I have a question.
Oh, yeah.
Sometimes the 0 has to have a line through it. What is that for?
Oh, no, that's only on the last question. If you get a 0 with a line through it, that means no solution. Let me go to that last one. I think like this one right here, these y'all seen those when we was doing these inequalities. And say I did have an answer when I clicked in, it would bring this up here. If you hit more, let me see if it's on here. Just see on the right side where my cursor's pointing, it says empty set. Are y'all seeing that? Maybe. Hey, is it showing my screen?
Yes,
It's not going over.
Oh, are y'all on the screen
Usually
that says?
You have to put the.
Say again.
Yeah.
Yeah, I can see it. It's showing underneath it when you put the cursor over it.
Yeah, it says empty set. All you had to worry about that. Some of the answers in here, they didn't have this. There is no solution, option B. So I showed y'all that you could put that empty set for those answers. That means no solution. But they give you a choice B on this, so you don't have to worry about that no solution on this problem, okay? Now, I think that's what you was talking about, right? The 0 with the line through it. All right, y'all, so let me write this one. I got an x minus 1, x plus 3, less than 0. And they want my answers in interval notation, which is how we were doing these. So this is what we learned yesterday. So to solve an inequality, they've already factored this one. So remember, we have to come in and set these factors equal to 0 and solve it. So the first one, I would add 1, and I get x is a positive 1. Second one, I would subtract 3 and get x is a negative 3. So remember, you had to set your timeline up, your number line, I mean. So negative 3 comes before 1. And then I always test 0. And for me, 0 is right in the middle of that negative 3 and 1. Now remember, if it's true, I shade that in between. If it's false, I don't shade that, and I shade the outsides only. So let's test our 0. Put a 0 into here. So 0 minus 1, 0 plus 3 has to be less than 0. So let's see what that gives me. Negative 1 times 3 is less than 0. Negative 3 less than 0. True or false? That is definitely true. So remember, since that was true, I would shade this section where my 0 was located at. Now, write that answer in interval notation. So my question is, I'm going to put that negative 3 first. Do I want a bracket or parentheses? And to answer that question, we look at this inequality up here. It's a less than. Yeah, it doesn't have equals on it, so you got to use your parentheses. Right, then on the right side, you ended at a 1, and the same thing, it uses parentheses. So, Donna Marie, to answer your question a while ago, say I had one of these and I couldn't factor it. If I can't factor them and get my 2 zeros, that's where I would use the 0 with the line through it and call it a no solution. But like I said, on these answers, it looks like they're giving y'all that choice B, so you don't even have to worry about that. All right, so I had parentheses, and I went from what? Negative 3 to 1. So you got to test those intervals and see which one's true and which ones make it false, okay? You know, I bet the last one, they're going to make me solve it all the way, but doing the same thing. So I got an x squared plus 17 is less than 8x. All right, so let's go work this one. So the first thing, you need to move that 8x over and get a 0 right there. So what I would do is subtract 8x from both sides. And I just throwed it in the middle because I know that's about where it's going to go, right? Because none of those are like terms. So I'm just going to put them in order. X squared minus my 8x plus 17 is all going to be less than 0. So now we're going to try to factor this. So this one, they want me to factor. The last one, they was nice, and they already factored that one. All right, so that's an x squared, so I'm going to put an x and an x. Last side's positive, and since that's positive, both factors will be negative like the middle number. All right, let's see, factors of 17 are 1 and 17, and oh, that's it. So I need a factor of 17 that adds to get an 8. Well, y'all, these factors are not going to add and give me an 8. So since this cannot be factored, what am I going to put? Donna Marie, I'm going to put a 0 with a line through it. So remember, that means no solution. So now, let's see. I think on this one, you actually had to use that because notice, they're not giving me a choice B on this, which says no solution. So if you notice on that, what are they putting on the answer bar down here?
No solution.
All right, so hit that empty set, put it in there, and be done. So, oh, I didn't want to do that, y'all. Oh hell, that was number 20, right? So that's it. So let me pull this share off. So y'all, we just went through the 20 questions you're going to see on that test. They might change the numbers up, but that's it. So practice your review. If you haven't done a review, practice it once or twice to get good, and then go knock out that test, okay? The review this time is exactly like the test. Alrighty, y'all. So any questions on that? And y'all remember, I sent a bonus, so I got some of y'all's bonus already. So if you want to do the bonus, remember, have it done by Sunday night also, okay?
All right.
Alrighty, so some of y'all were asking about 5.4 support. I unassigned it because it wasn't in line with what it was supposed to be. They got them out of order, so I just unassigned that one. So you might see it in Blackboard, but it's not going to hurt anybody's grade at all, okay? Alrighty, so let's stop recording this.